Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your chapter number 9, that is virtual memory. In the last class we have discussed the previous topic, that is the 9 topic, that is the main topic that is used, and the today's topic is the garbage collection. In the last class we have discussed about the dynamic memory allocation, that is how dynamically memory will be allocated, that is a dynamic memory allocation. But the today's topic is the garbage collection, that is a today's topic. But before going to the next topic, that is the garbage collection, let's take a quick review what we have covered in the last class. In the last class we have studied about the that is dynamic memory allocation, how dynamically memory will be allocated in the computer system. This is the yesterday's topic, that is dynamic memory allocation. In this we have studied that there are generally two functions that is used. One is a memory map, that is a mmap. One is your memory un map, that is the unallocated mapping, that is the mun map function to create and delete the areas of the virtual memory. This is the diagram that we have discussed, that is the how dynamically memory will be allocated. Whenever in simple terms, dynamic memory allocation means the memory will be allocated to the different processes program whenever there is a new requirement, whenever there is an additional requirement of the memory at the runtime. So dynamic memory allocator requires or need or allocates the memory to the new process, to the existing process at the runtime whenever there is an additional requirement of the memory. A dynamic memory allocator allocates or maintains an area of a process virtual memory known as the heap. So this says a dynamic memory allocator maintains or runs an area of the process virtual memory that is known as the heap. So the memory that is allocated at the runtime, that is known as the heap. Details vary from system to system, but without loss of generality, we will assume that the heap is an area of demand zero memory that begins immediately after the uninitialized BSS area. So this means whenever there is a huge requirement, the memory will be allocated at the runtime, and that portion of memory is known as the heap. So heap is a memory that is allocated at the runtime, that is the dynamic memory allocation. Then allocation may be done in a fixed size, in a variable size, that is allocation of memory can be done in a variable size blocks, that is the blocks of the size of the blocks of the memories of different types, or it is of the fixed type also or fixed size also. So whenever we say dynamic memory allocation, so there is a one term that is used, is the dynamic memory allocator that allocates the memory at the runtime. So in dynamic memory allocation there are two types of allocators that is used. So in simple terms, allocator comes in two basic styles or two varieties. One is your explicit allocators, one is your implicit allocators. Explicit allocators requires the application to use free or to use the memory that is allocated in the blocks. For example, the C standard library functions provides a malloc function. So there are two functions that is used in the C language. One is malloc, that is used for allocating the memory. One is your free function that is used to deallocate or uninitialize the memory. But in C++, that is a different programming language, that malloc function is replaced by the new function, that is new function is used to allocate the memory, and delete function is used to deallocate the memory. So malloc is replaced by the new and the free is replaced by the delete. So this is comes under the explicit allocators. In the same way, next category of allocator that we have studied is Implicit allocators, that requires the allocator to detect when an allocated block is no longer being used in the programs. That implicit allocators is done by the is also known as the garbage collector, that collects the garbage at one place, places all the garbage at one place, simply uh, executes the process so that process execution will takes place efficiently and effectively. So that is done by the implicit allocators. So this is the today's topic, that is the implicit allocators. In the last class we have studied malloc, calloc, new, delete, free functions. This says the process of automatically means that is not done man-made, that is we cannot use any function, that is we have done in the explicit allocator, that is we have to use the C programming language and aligning or designing the malloc, calloc, free function, new function, delete function. But the process of automatically removing the unused block, unused memory is known as the garbage collection. So in simple terms, explicit allocator is done manually, while the implicit allocator is done automatically. That is, it automatically allocates or it automatically free the allocated blocks, that is done by the garbage collection. For example, the high level languages such as Lisp, ML and Java also uses the garbage collection to free allocated the blocks. Then we have studied about the malloc and the calloc function. That is, what is a malloc function, why we are using the malloc function, what is the syntax of the malloc function, that is used for allocating the memory, and the free function that is also used to deallocate the memory. This is also the function that we have studied, that is the sbreak function or the sbrk function, that grows or shrinks the heap by adding increment to the kernel's break pointer. This is the diagram that shows the malloc that we have studied. First of all, the malloc is used for allocating the memory, and that allocated part is stored in the P1. Then for P2 it is allocated, for P3 it is allocated. Then free the P2 part, that is the memory that is used for the P2 process, is released or deallocated by using the free function, that is the free P2. Again, P4 is used for allocating the memory, that is done by the P4. Then why we are using the dynamic memory allocation, means what is the main motto, why we are using the why there is a requirement for the dynamic memory allocation. That is the main need, because in any programming language the memory will be allocated or memory will be cluttered at one place. So it is very necessary that we can allocate the memory at the dynamic time whenever there is a requirement for the process. Then we have studied that the allocator requirements and the goal, that is what is the requirement and what are the goals for the allocator that is used, that is either explicit allocator or implicit allocator. What is the main goal? Making the immediate response to the request, that is at the runtime if there is a request by any process, so that needs or that gives the immediate response, that is also the main goal of the explicit allocators. Using only the heap, that is it uses only the heap memory, so that memory will be allocated at the runtime. Next goal is aligning the blocks, non modifying the allocated blocks. These are the basically requirements, or these are the goals. Next goal is, or goal 1 is maximizing the throughput, that is the output is also maximizing, that is the goal 1. Then goal 2 is maximizing the memory utilization, that is maximize the memory utilization. Then we also studied the next topic, that is the fragmentation. What is fragmentation? That is dividing the heap into different parts, that is the dividing the memory that is allocated at the runtime into different blocks, into different parts, that is known as the fragmentation. which occurs when otherwise unused memory is not available to satisfy the allocate resources. That is, when we do the fragmentation, that is used for the memory that is not available to satisfy the allocated resources. There are generally two forms of fragmentation. One is internal fragmentation, one is external fragmentation. Internal fragmentation means the fragmentation that occurs when an allocated block is larger than the payload, whereas the external fragmentation is a fragmentation that occurs when an allocated block or when there is enough aggregate free memory to satisfy an allocated request. Then we have studied what are the implementation issues. That is, if we implement the memory, that is, if we implement the fragmentation in the memory, that what are the critical issues or what are the issues that is available. The simplest image level allocator would organize the heap as a large array of bytes and a pointer p that initially points to the first byte of the array. To allocate the size bytes, the malloc would save the current value of p on the stack, increment the p, and then return the old value to the caller. So these are the various issues. That is, there is a mismatch between the calling function and the caller function. So that implementation issue is also resolved by the virtual memory that is used in the programming language. A practical allocator that strikes a better balance between throughput and utilization must consider the following issues. So these are the issues that is available whenever we use the or whenever we strike a balance between the throughput and the utilization. What are the issues that occurs? One of the issue is free block organization. That is, there is no how we keep the free blocks. That is how we deallocate the memory. That is a free block organization. Then placement, that how we can place the content in the free blocks. Then splitting, that how newly allocated blocks will be splitted into multiple parts. Then coalescing, that is how we can or what we can do within a block that have been freed. That is the block that is freed, what we can do. Then we have studied about the implicit free list. This is the format of the simple heap block that we have studied. This is how to organize with the implicit free block. Then we have studied how to place the allocated block. So these are the issues that is implementation issues that is discussed one by one. So how we can place the allocated block? By using the placement policy that is divided into three parts. One is first fit, then next fit, then best fit. So these are the three policies, or these are the three placement policies that is available to place the allocated block. Then we have discussed how to split the free blocks, that is how to split the multiple parts or how to split the free blocks that is available at the runtime. Then next what we have said is how to get the additional heap memory. That is, if I need a memory, that is how to get the additional heap memory that is required. Then how to coalescing the free blocks, that is how to collide or how to combine all the free blocks into the one place, that is the coalescing the free blocks. And there are also two types of coalescing that is available for the allocator. One is immediate coalescing, one is deferred coalescing. Immediate means that is done at the same time, whereas the deferred coalescing that is done at some later time. Then next is your coalescing with boundary tags. How to use the coalescing with the boundary tag that is available for the current block. This is the diagram that we have studied in the last class. These are the example of different cases. There are 4 cases that is used, that is coalescing, how to collide with the boundary tags. Then we have studied about the simple allocator, that is what we have covered, like allocating, splitting into multiple parts. These are the various examples that we have studied in the last class. Then how to free and coalescing the blocks, how to allocate the block that we have studied. Then how to explicit the free list, that is how to explicit or how to exclude the free list that is available. Then we have studied how to segregate the free list, how means how to divide the free list into multiple parts, that is divided into two parts, that is simple segregated storage. One is only segregated fits. Then we have also studied about the buddy system, that is what is buddy system, why we are using the buddy system. That is special part of the segregated file. That is what we have covered in the last class. Now let's start with the new topic, that is basically the part of the yesterday's topic. In yesterday's topic we have discussed the one of the allocator, that is a explicit allocator. In the today's class I will talk about, or I'm talking about the next allocator, that is a implicit allocator, that is done by the garbage collection. So one is yesterday we have studied about the implicit. Yesterday we have studied about the explicit allocator, but today we have studied, or we will going to study about the implicit allocator. That is done by the technique that is known as the garbage collection. So garbage collection is a technique of the implicit allocators. This says with an explicit allocator such as cmalloc package on an application, such as cmalloc package, an application allocates and frees the heap blocks by making the call to the malloc and the free. This says whenever we use the explicit allocator, we use the two functions, that is the malloc and the calloc, for allocating and deallocating the memory. Malloc and the free function for allocating and deallocating the memory. It is the application responsibility to free any allocated block that is no longer need. So whenever we use the explicit allocator, the main responsibility goes on the application to free the memory whenever there is no requirement, whenever there is no need for the memory. So failing to free allocated block is a common programming error, because application must perform so many tasks. So it is not in the hand of the application to clear or to free all the allocated blocks. So that is also a main measure or the common programming error that is generally available in every application. For example, consider the following C function that allocates a block of temporary storage as part of the processing. That is, if I am using void garbage, that is garbage is a function that returns the value of return type, then int pointer p, that is using the pointer variable, that is a p, that stores the value of the int pointer malloc, that is first of all allocating the memory, then allocate the memory by using the malloc function, then store the output of the memory space that is required in the, and store the output in the pointer p, then return the value. How to return the value? This says array p is a garbage at this point, that is array p is available, that is a garbage collection at this point. Since p is no longer needed by the program, it should have freed before garbage returns. Unfortunately, the programmer have forgotten the free block. So this is the example, that is why we are using the garbage collection. This is the example of the malloc function or the explicit allocator. This says unfortunately it is the programmer has forgotten to free the block. It remains allocated for the lifetime of the need, needlessly occupying heap space that could be used to satisfy subsequent allocation request. Now next term that is used is the garbage collector. So a garbage collector is a dynamic storage allocator that is also a part of the implicit allocator that automatically frees the allocated block that are no longer needed by the program. So in malloc function, it is the responsibility of the application to manually free the block of the memory whenever there is no requirement of the memory. But in with the help of the implicit allocator, with the help of the garbage collector, uh, that automatically frees the allocated blocks that are no longer needed by the program. Such blocks are known as the garbage. Means the blocks that is freed by the memory are needed or are known as the garbage. Hence they are known as the garbage collector. The process of automatically reclaiming heap storage is known as the garbage collection. So in simple terms, whenever the memory will be freed, so a new process arrives, that is a garbage collection, that automatically free the memory or free the allocated blocks that are no longer needed by the program. So that is known as the garbage collection. And garbage collector is the allocator that is done or that is doing the task of the garbage collection. In a system that supports garbage collection, application explicitly allocate heap block but never explicitly free them. That is, whenever we are using the garbage collection, then allocation is done by the malloc function only, but deallocation is done by the garbage collection, because it automatically garbage or it automatically deallocates the memory whenever there is no requirement of the memory. In the context of C program, the application calls malloc but never calls the free. As I told you, it allocate or it store or it uses the malloc function or it calls the malloc function but never calls the free function. Why? The main reason is that the allocation is done by the in explicit mode, but the deallocation is done by the automatic mode, that is a garbage collection. Instead, the garbage collector periodically identifies the garbage blocks and makes the appropriate calls to free to place those blocks back on the free list. So it is the role of the garbage collector to collect the garbage whenever there is a free memory. Now, garbage collection date back to Lisp system developed by John McCarthy at MIT in the early 1960s. So this is the this is the history of the garbage collection, that how garbage collection is used. It is an important part of modern language systems such as Java, ML, Perl, and it remains an active and important area of the research. So this describes as amazing number of approaches for the garbage collection. This says there are various approaches, there are various techniques that is available for the garbage collection. The various technique that is available, one of the technique that is the mark and the sweep algorithm, which is interesting because it can build on the top of the existing malloc package to provide the garbage collection for C and C++ program. This says it was developed by the by the John McCarthy at the MIT in the 1960s, that is using or that is used or the garbage collection, and various technologies are used for the garbage collection, and one of the best technology that is used in the garbage collection is mark and sweep collection, or the mark and sweep mark and sweep algorithm, that marks the content and then sweep the contents of the memory, then free the memory. Now next part is your garbage collector basics, that is what is the garbage collector, what are the basics of a garbage collector. Now let's see with the help of PPTs. Chapter number 9, that is virtual memory continued. The topic is garbage collection. Now first of all, what is a garbage? What is a garbage means? What is a garbage? That is, almost all garbage collectors assume the following definition of 5 objects known as liveness by the reachability. If you can get to an object, then it is live. So garbage means any dump area, anything that is not required by the process, that is the garbage. More formally, an object is live if and only if it is referenced in a predefined variable known as the root. That is, the object is live means the object is available or live if and only if it is referenced in a predefined variable, it is available or used by the predefined variable known as the root, or it is referenced in a variable contained in a live object, that is it is transitively referenced from a root. That is only used for the live object, but whenever there is a non-live object that are known as the dead object, that is known as the garbage. So whenever there is a live object, that is process is using the object, whenever there is a predefined variable, that is known as the root or the live object. But the non-live objects, that is dead objects, are known. Dead objects means that is not required. The dead objects are known as the garbage. So garbage means the dead objects that is not used by the process anymore. Now what is a graph and what is a root? As I told you, first of all we mark on the algorithm, or we use the mark and sweep algorithm. So first of all mark the content, mark the nodes of the graph, and then clear the content. This says the object and references can be considered a directed graph. That is, the object and the references that is used can be considered, can be available as a directed graph. The live objects are those reachable from a root. That is, the live objects are the content, are the objects of the graph that are reachable from the root, that is, that are connected from the root. The process of executing a computation is known as the mutator, because it is viewed as dynamically changing the object graph. Now what are the roots of a computation? That is, what are the roots that is available? Determining roots is in general language dependent. That is, the whenever I say that is determining the root, that depends on generally, or that generally depends on the language. So it depends on the language to language. If I'm using the programming language, that is C, so that is totally different of the roots. And if I'm using the C++, that is totally different. So determining roots is totally dependent on the language. In common language implementation, roots includes words in the static area, registers, words on the execution stack that points into the heap. So roots includes, or roots technology includes static area, registers, words on the execution stack. Now why garbage collect? That is, what is the main motto? Why we can collect the, or why garbage collects the unallocated files? There is a language requirement. Many OO languages, that is the object oriented languages, such as most or many object oriented languages assumes GC. Assumes GC means that there is a GC that is available. Example, allocates the object may survive much longer than the method that created them. Now what is the problem requirement? The nature of the problem may make it very hard, impossible to determine when something is garbage. Now next part is why GC is a software engineering issue. This is that is the why GC is used, or why GC is a software engineering issue. That is why we are using the garbage collection, and what is the main motto, or why we are using the garbage collection as a software engineering issue. So SC means the management of complexity in a large scale software system. That is the software engineering, that is a management of the complexity, management of the content in a large scale software system. Now what are the tools available for SC, that is software engineering? There are two tools available. One is modularity, one is abstraction. This says explicit MM cuts again these principle. Auto MM, explicit means that whenever we use the MM means memory management. So explicit memory explicit memory management means whenever we use the manual functions like malloc, free, new, delete. And auto MM means that increases or increase the abstraction, that is it offers the increased abstraction. Next is your relieve programmers of bookkeeping details. Time is better spent on high level details of design and implementation. Now next is what are the major areas of memory, that is from where we can get the memory, what are the major areas. First area of major where we can get the memory is the static area. Static area means the fixed size. Suppose I am writing the C program and allocates the memory, that is the fixed size that is not required, or that is not rotated by other, that is not a variable size, that is a fixed size. Next is fixed content, next allocated at the compile time. So all the data, all the memory that is of fixed size, that has a fixed content, that is allocated at the compile time, comes under the static area. So that is the major area of the memory. Then next major area that is available for the memory is the runtime stack. That is the next category, that is the variable size. That is the memory is used at the runtime, that is of variable size, variable content, then used for managing the function calls and returns. Generally, the variable size data or the variable runtime stack is used for the initializing the memory or for calling and returns the function. Next area of memory is heap. So one is static area, that is available or allocated at the compile time. One is runtime stack, that is allocated at the runtime. One is heap, that is also of fixed size, variable content, but dynamically allocates the object in the data structure. For example, malloc in C, new in Java or C++. So heap is the memory that is available at the runtime whenever there is a requirement for the memory. Now next is what is the cell and what is the liveness. Cell is the data item in the heap. That is, heap is a memory that is allocated at the runtime, that is used at the runtime. So any cell is known as the data item in the heap. So any data item is known as the cell in the heap. Cells are pointed to by pointers that held in the registers, stack, global static memory, or in other heap cells. So cells are pointed by the pointer, or cells are used as a pointer by the and held in the registers. Then what are the roots? That is the registers, stack location, global or static variable, that are known as the roots. And a cell is known as the live if its address is available in a root or held by another live cell in the heap. So if I say the object is live, that is it is used by someone or it is available in the root part, that is it is directly connected to the root in the tree, that is a live. But whenever we say that the process is not live, that is a dead object. That means the dead object that is not longer available. So that dead object is getting or is obtained by next concept, or is getting by next concept, that is known as the garbage collector. So a cell is live if its address is held in a root and held by another live cell in the heap. So its address is held in a loop. So in simple terms, last line shows the difference between the live objects and the dead objects. Live means whenever its address is available in the root or held by another live cell in the heap. Next point says garbage is a block of heap memory. Block of heap memory means it is a part of the heap memory, block of the heap memory that is available, or that automatically that cannot be accessed by the program. So garbage is not accessed by any program, but it is get together, or it is accessing the memory that it is allocating the unallocated memory and used by the programmers. This says an allocated block of heap memory does not have a reference to it. Cells is no longer live. That is, garbage is a memory, or garbage is a collection where there is a allocated block of heap memory that does not have a reference. That does not have a reference. That is, the cell is no longer live. That is, data is not available no longer. Then another kind of memory error is a reference exists to a block of memory that is no longer allocated. That is the next error that is used. Next, garbage collection. So this is the garbage that is used for the dead objects. Next is your garbage collection. So one is garbage collection. That garbage, that is the dead objects, are collected or are automatically managed by the garbage collection. So this says automatically or automatic management of dynamic allocated storage, that is the garbage collection. That is, we can automatically allocate or we can automatically manage the dynamically allocate storage, that is reclaim unused heap blocks for later use by the program. Next is your example of the garbage, that is, this is the example how garbage is available in the memory. One is class node, that is a class is declared in C++, there is a node, that is a class name. Then two variables are initialized, one is of value, that is of int type, one is of next, that is of node type. So one contains the value, one contains the address. Now close the class node, then declare the two variables of the node, that is the p and the q. Just this is the class portion, or the class approach is the same as of the struct. Struct is also a variable user defined data type. In the same way, class is also a user defined data type. So p is allocating, or p is getting the value of the new node, q is also getting the value of the new node, p is stored in the queue, and then delete the p. So this is how how the garbage collection is maintained. First of all, p is maintained, q is maintained, then p, q both are maintained, then p contains the null values. Why? Because it is used for the new node. Then q, there is a question mark, then there is a c. Now what is the use, why we are using the garbage collection? Today's programs consume storage freely, that is the today in the today's scenario, programs consumes, or the program uses the storage very freely. That is, it contains or it requires 1 GB laptop, 1 to 4 GB desktop, 8 to 512 GB servers, 64 bit address spaces, and so on, and mismanage it. How to mismanage it? Like memory leaks, dangling references. So these are the various methods of the dead objects. Why we are not using the memory? Why there is a huge collection of the dead objects? That is the main that is why there is a garbage in the computer. So this is the memory leak, dangling references, double free. That is we can free the content double in a double way. Misaligned addresses, null pointer difference, and the heap fragmentation. So these are the various ways why we are gathering the, or why we are holding the garbage. Next, poor use of reference locality resulting in high cache miss rate and or excessive demand paging. Then next is explicit memory management breaks high level programming abstraction. So garbage collection is the explicit memory management that breaks the high level programming abstraction. So that is the next point why we are using the garbage collection. Now garbage collection and the programming languages. So what is the main link between the garbage collection and the programming languages? Garbage collection, that is a GC, is not a language feature. That is not dependent on any language. Garbage collection is available in any programming language. It may be C, it may be C++, it may be Java. So it is available in any programming language. GC is a pragmatic concern for automatic and efficient heap management. So garbage collection is also a concern, or the important terms that is used for the automatic, that is automatically deletes the memory, that is used for automatic and efficient heap management. Heap management means allocating or deallocating the memory in the heap. That is, it is available at the runtime. Then it is a cooperative languages, that is the use in the GC is the Prolog, Smalltalk, Scheme, Lisp. And the uncooperative languages are the languages that we generally use. We means as a user, that is the C and the C++. But garbage collection libraries have been built for the C or the C++. Now next is recent GC revival, that is the recent how GC is revived or how GC is revived. That is the object oriented languages, module 3 Java, in Java, there is a low priority, and so on, so on. These are the functional languages that is used. Now, the perfect garbage collector, that is, if I say there is a perfect garbage collector, so what do you mean by the perfect garbage collection? Now let's see what is a perfect garbage collector. No visible impact on the program execution. That is, if I say that this garbage collector is a perfect, that does not give the visible impact on any program execution. That is also a main part, that does not give, or there is no visible impact on the program execution if there is a perfect garbage collector. Next is your works with any program. That is not that garbage collector is depend on the program. No, it works with any program and any data structure, or with its data structure. For example, handles cyclic data structure. So that is the main way why we are saying that that is a perfect garbage collector. Then the perfect garbage collector also collects the garbage and only garbage cells quickly, has excellent spatial locality of reference, that is no excessive paging, no negative cache effects. So that is also the main feature or the main advantage of the garbage collector. Next, manages the heap efficiently. So if I say that is a perfect garbage collector that manages the heap efficiently and effectively, that always satisfies an allocation request and does not fragment the data. Now, these are the GC techniques, that is the garbage collection techniques, that is that will be studied in the later few slides. So first of all, let's take a quick review with the help of the book also. Now, these are the garbage collector basics. This says a garbage collector view memory as a directed reachability graph of the form shown in figure 49. Now let's see figure 49. These are the root nodes, these are the heap nodes. These are reachable, that is we can reach the data of these circles, this one, this one, this one, this one, this one, this one, and these are the unreachable, that is a garbage. We cannot reach this one, this one, this one, this one. Means we cannot reach, that is a unreachable data. That is the garbage collector view of the memory as a directed graph. So this is the basic that I told you with the help of PPT. That is, we can use the garbage collection on the directed graph. This says the nodes of the graphs are partitioned into the set of the root node and the heap node. So this is the main branches are known as the root nodes, and the next level branches are known as the heap nodes. Each heap node corresponds to an allocated block in the heap. A directed H, that is the P to Q, that is the directed graph. This arrow indicates the direction that some location in block P point to some location in block Q. That is, P is pointed to the Q. That is a directed graph. But if there is a simple line, there is no arrow. That means that there is a undirected edge. So directed edge means if there is an arrow, that means one direct to the another. If there is simple line, that is the undirected edge, that does not direct to any point, or that does not direct to any node. This says, we say that a node P is reachable if there exists a directed path from any node to the P. That is, if we can access any node, so there is a mandatory condition is that the arrow will also be available. Garbage collector for languages like ML and Java, which exert tight control over how application creates and use the pointer. So this is the example of the garbage collector view as a directed graph. Next, how to integrate a conservative garbage collector and a cmalloc package. That is, how to we can integrate the multiple applications together. First of all, there is a C application program. Then dynamically the memory will be allocated by using the malloc function. Then conservative garbage collector is used, and that memory is released by the free function at the end. This says Collectors can provide their service on demand, or they can return a separate threads in the parallel with the application, continuously updating the reachability graph and reclaiming the garbage. For example, consider how we might incorporate a conservative collector for C program into existing. This is the example how we can use a conservative garbage collector. This is the best. This is the main paragraph that is used. The application calls malloc in the usual manner. That is, if there is any application program that is a C++ that calls a malloc function in the usual manner in the similar manner whenever it needs the heap space. So any C program language that needs the any program that needs the memory, that request for the memory at the runtime, simply uses the malloc function for allocating the memory. If malloc is unable to find a free block that fits, that is, if the free block is not available with the help of the malloc, then it calls the garbage collector in hope of reclaiming some garbage to the free list. So first of all, it tried with the help of the malloc function. If does not get the data, then it is going to the conservative garbage collector. The collector identifies the garbage blocks and return them to the heap by calling the free function. So it returns the value, it gets the value, it gets the garbage blocks and return to the heap by calling the free function. The key idea is that the collector calls the free instead of the application. When the call to the collector returns, the malloc tries again to find a free block that it fits. So when the call is going to the collector returns, then malloc again tries to find a free block, and if again that fails, then it asks for the operating system for the additional memory. So malloc is the function that is used for the allocation of the memory. If the allocation is not available or is not performed by the malloc function, then it goes to the conservative garbage collector. Then it frees the memory that it fits, and again if that garbage collector or the malloc function fails for getting the memory, then it asks for the operating system for the additional memory. Eventually malloc returns a pointer to the requested block or the null pointer. Now next is your mark and sweep garbage collector. That is I think the technology of the mark and sweep. Yeah, this is a summary of the GC techniques. That is what are the GC techniques, garbage collection techniques that is available. One is reference counting, that directly keeps tracks of the live cells. Cells means the different nodes of the trees or different nodes of the blocks. That is one of the technique is known as the reference counting, that directly keeps a track of the live cells. GC takes care whenever heap block is allocated. GC take care means GC take care of the technique whenever a heap block is allocated. It does not detect all the garbages. So reference counting does not detect all the garbages that is available. Now what are the next technique is the tracing. So one is the reference counting, one is the tracing, that GC takes a place and identify live cells when a request for memory fails. Then next technique that is used for the tracing is the mark sweep, one is the copy collection. Modern technique that is used is the generation GC. So these are the various techniques of the GC that is available. One is reference counting, tracing, mark sweep, copy collection, generation or generational GC. Now let's start, or let's first of all take 5 to 10 minutes break and then come back, then start with the techniques that is available for the garbage collection, starting with the technique that is a reference counting. So first of all, let's take 5 to 10 minutes break, then come back starting with this topic. So have a break. Now let's start with the techniques of the GC, that is the garbage collection. So come back from the break. Let's start with the terminology, techniques that is used, that is the reference counting or mark and sweep. So first of all, let's take a quick review, or first of all, let's take a review on the reference counting. This says it simply counts the number of references to a cell. References means it counts the number of requirement of the memory, that is the addresses that is used to a cell. Then it also requires the space and the time overhead, that is the how much time and the how much space it is required to store the count and the increment each time a reference is added. So whenever a reference is added, how much time it requires or how much space it requires, that is also comes under the reference counting. Reference counts are maintained in real time, so no stop and gag effect. Incremental garbage collection, that is it increments the garbage collection. Then next is your Unix file system uses a reference count for the file. So Unix file system also uses the file system that is uses a reference count for the files. C++ smart pointer, that is example of the auto PTR, uses the reference counts. That is also the reference counting. Then this is the example of the reference counting. Then root is indicated by this one. Then next part is also indicated by this one. Next part is indicated by this one. Now, so one root set is allocated or linked with the one block. Another root set is linked to the another set. Next root set is linked to the another set. That again routed to the next one. Now this is linked to the 1. This is linked to the 1, 2. This is linked to the 2, this is linked to the 1. So this is how we can reference or we can attach the various memory with each other by attaching with the help of a reference. Reference means the addresses, that is known as the reference counting. So this is also related to this one, this is related to this one, this is related to this one. Now what is reference counting? That keeps count of the number of references. As I told you, it updates the count in response to the operation, that is initialize, increment, decrement. Initialize means create or clone, that is how to create and how to initialize the variables. Increment means assignment method call, that is we can assign the value, we can call the method, or we can call the function. Then in decrement there is also assignment, there is also a method to return, that is also a decrement method. Next, what are the limitations? That is the space and the time overhead to maintain the count. That is, it requires some more space, it requires some more time, that is, it is very costly to maintain the count. Then memory leakage when cycles in data. So whenever there is a cycle like this one, there is a sometime memory leakage. So this is also a limitation. Now what are the advantage, or what is the advantage? Incremental algorithm. Why it is known as incremental algorithm? As you see, this is linked to this one, then this is linked to this one, this is linked to this one, again that is linked to next one, next one, next one. That is a incremental algorithm. Then what are the applications? Means where it is used, that where this algorithm, that is a reference counting method, is used, that is used in the Unix file system, Java RMI, string, COM, DCOM, pure functional language, scripting languages. So these are the applications where this function, that is a reference counting function, is used. Next is garbage collection, that is detecting and reclaiming the unreachable objects automatically, soundnet, safety that I covered. Now reachability is an approximation. Consider the program, this one. Now what are the strength of the reference counting? Means what are the advantages of the reference counting? First of all, incremental overhead, that is cell management interleaved with program execution, that is good for interactive or real-time computation. It is relatively easy to implement. So these are the various advantages. One of the advantages is that it increment the overhead or incremental overhead. Then relatively easy to implement, easy coexist with manual memory management. So this is the automatic memory management, and it is also exist, or it also cooperate with the manual memory management, that is with the help of that is with the explicit allocators. Then spatial locality of reference is also good in this. Then can also reuse the freed cells immediately. That is, it also reuse the same cells or the freed cells immediately. That is, put the free cell in the space and allocates the memory or in the free cell immediately. Now, what are the limitations? The space overhead, that it requires more space for counting the overheads, for counting the material, for counting the things. That is one word for the count. That is, it counts the one word for the one word for each count, one word for the indirect pointer. There is a time overhead, that is updating a pointer to point to a new cell requires check to ensure that it is not a cell reference. Decrement the count by the old cell. So these are the various time overheads that is required whenever we use the reference counting. Then next limitation, next weakness is that one missed increment decrement result in a dangling pointer memory leak. So whenever we use the reference counting, one may miss the dangling pointer or the memory leak. Cyclic data structure may cause leaks. So this is the cyclic data structure, that is, it may leak the content. So this is whenever it is linked to this one, it may leak the content, it may bring the unsecure data. That is the main limitation. This is the memory leakage. This is also linked to this one, this is also linked to this one. Now next these are the techniques, that is how it these limitations, that is the memory leakage, is removed by using the smart pointer that is used in the C++, that is similar to std, auto, ptr, tin, and sci C++. This is the reference object, this is the reference object, that is the object of the type t. This is the implementation, this is the example in C, this is the example in C++. Then how to use the smart pointer, this is also the example in C++. Now next method or the next technique is mark sweep garbage collection. That is the next technology that is used, is the mark sweep. This is one of the new technology, one of the used technology that is used in the day-to-day scenario. That is a mark sweep. As the name advice, mark sweep. First of all, mark the cells and then sweep means removes the content. That is a mark and sweep garbage collection. A mark and sweep garbage collector consists of a mark phase. That is, it consists of a mark phase which marks all the reachable and allocated descendant of the root node. That is, it marks or it allocates or it marks all the reachable, that is we can reach, and the allocated descendant of the root node. That is, first of all, it marks the descendant, that is the lies under the category of the root node, followed by the sweep phase. So first of all, a mark phase that marks the allocated descendant, then it is followed by the sweep phase which frees each unmarked allocated block. So first of all, as I told you, mark the descendant, then freeze the memory by using the sweep phase. Typically, one of the spare low order bits in the block header is used to indicate whether a block is marked or not. So that is used, or that is also used to indicate whether a block is marked or not. Our description of mark and sweep assume the following function where ptr is defined as a type def void ptr. This is the example, that is ptr is ptr p. That is, if p points to some word in an allocated block, returns a pointer b to the beginning of that block, returns a null otherwise. It also returns a true if the block b is already marked. So this is the example, that is the function that is used by using the pointers. So this is ptr is ptr, that is the pointer is used. Then int block mark, that is a ptr b, that is returns the value true if and only if the block b is already marked. Then int block allocated, that is a ptr b, that is return the true if block b is allocated. Then this is the next function, that is the int length, that is a ptrb, that returns the length in the words of the block B, that changes the status of the block B from marked to the unmarked. This is the example for the mark and the sweep. This is the mark function that is used in the C language. This says pseudocode for the mark and the sweep. Now let's see, this is a very interesting topic. This says void mark ptrp, that is the mark function is used that has a return type of void, and the argument that is used is the ptr, that has a variable p. Now curly braces open, if b equals to is ptr, p equals to null. This is the same example. These are the functions that is used. Is ptrp, that points to some value, returns a pointer b to the beginning of that block, return null otherwise. That's why it is using the equals to null, that is if this output is not is equals to the null, then return otherwise. If block mark, that uses the next function, if there is a block mark, if the mark is not available, that is block, again return the value. Then mark block B, counting the length of B and putting the output in the length variable. Then uses the for function, that is I equals to 0, I is less than len, I plus plus. Then mark bi, that is using the 0, 1, 2, 3, 4 till depend on the length of the b. So this is the mark function, how descendants of the root node are marked by the mark and sweep function or mark and sweep algorithm. Next is your sweep function, how sweep will be maintained. First of all, using the function that is a void sweep. Sweep is the function name, void is the return type. Then ptrb uses two variable, two argument, one is of b, one is of end. Then while b is less than end, that is it is available till b is less than end. Then curly braces start, if block marked b, that is if the block mark, that is the if I am using the block mark, that is the mark that is block is the contained in B, then unmark the block B, else block allocated B, that is allocated by B, that is blocked, and then free the B block. Then store the output of the next block B into the B, that is how it will release the memory. Then free the B means sweeping the memory, that is done by the sweep function, that is the next block B. Then there is a return function, then curly braces close. This says the mark phase calls the mark function shown in 51a once for each root node. The mark function returns immediately if p does not point to an allocated block, and so on, that I discussed with the help of the example. Next, the sweep function is a single cell to the sweep function shown in 51b. The sweep function iterates over each block in the heap, freeing any unmarked allocated block. This is the unmarked allocated block, that's why it freed the b only, that is the b variable only. Figure 52 shows a graphic implementation of the mark and sweep for a small heap. Block boundaries are indicated by the heavy lines. Each square corresponds to a word of the memory. Each block has a one word quarter which is either marked or unmarked. This is the root, this is the boundaries that is used, these are the boundaries that is denoted by the dotted dark lines. These are the two contents that is used. This is before the mark, this is after the mark. This is the unmarked block header, this is the marked block header. This is denoted by the light gray, this is denoted by the dark gray. This is 1, then 2, 3, 4, 5, 6. This is after the marking, that is this is marked, this is marked, this is marked, this is marked. Then after sweeping, that is it free the memory, it free the memory. Note that the arrows in this example denotes memory references and not the free list pointers. Now next is conservative mark and sweep for the C program. This says it is an appropriate approach for the garbage collecting C program because it works in place without moving any blocks. However, the C language poses some interesting challenges for the implementation of the isPtr function. First, C does not tag memory location with any type information. That is, it does not tag, it does not affect any C programming language, any C language that is using the function that is used to determine if the input pointer P is a pointer or not. Second, even if we were to know that P was a pointer, there would be no obvious way for isPtr to determine whether P points to some location in the payload of an allocated block or not. So there is no criteria to determine whether isPtr contains the P variable to some location to the payload of an allocated block or not. The isPtr function uses the free function or the tree to perform a binary search of the allocated block. At each step, it relies on the size field in the block header to determine if P falls within the content or extent of the block. The fundamental reason that mark and sweep collector for C program must be conservative is that the C language does not tag the memory location. As I told you, it does not tag the memory location with the type information. This is the left and the right pointer in a balanced tree. This is the allocated block header. There is a size, there is a left, there is a right, and there is a remainder of the block or the remainder of block. Now let's see with the help of PPTs. This says mark sweep garbage collection. Each cell has a mark bit. That is, each cell that is used, each block that is used has a mark bit. The garbage means the reachable and undetected until heap is used. So garbage means unreachable, that is we cannot reach the content, and the undetected, that we cannot detect until heap is used up. Then GC goes to work, that is garbage collection goes to work. That is, garbage is not unreachable or garbage is clutter, but we cannot detect the garbage in the heap. Then garbage collector uses or goes to work on while program execution is suspended. This means garbage is unreachable and undetected until heap is used up. Then GC goes to work, that is GC is going to work, that is garbage collection is going to work while the program execution is suspended. That is, while program is suspended, GC is going to work. Then marking phase and the sweep phase. That is, the marking phase that starts from the root, set the mark bit on all the live cells. That is the marking phase. Sweep phase means that returns all the unmarked cell to the free list. So marking phase means starting from the root, set the mark bit on the live cells, that is marking the cells that have a free memory, that is that have been allocated and deallocated, and then free the memory by using the sweep phase. In sweep phase, it returns all the unmarked cell to the free list, reset the mark bit to the marked cells. Now this is the algorithm that is used, garbage collection. The algorithm that is used is the depth first search to mark live data cells, that is cells in heap reachable from variables on runtime stack. Next, garbage reclamation, that is sweep through the entire memory. So this is the algorithm. First of all, there is a garbage collection that is done by using the mark function. Then garbage removal, that is garbage reclamation, that is done by the sweep function, that is sweep through the entire memory, putting unmarked nodes on the free list, sweep all unmarked the marked nodes. So this is the algorithm that is divided into two parts. One is mark, one is sweep, and the mark is also known as the garbage detection and the garbage reclamation. First of all, there is a mark phase. This is the mark phase. This is the function, that is the depth first search, DFS. If R is a reference variable and object are not marked, then mark the object R. That is, if R is a reference mean that is referred or that is used for the removal, and that is not marked, that is object R is not marked, then mark the object R, that is T is greater than -1, stack T greater than less than -R, while T is greater than 0. That is the condition. It is runs till T is greater than 0. Then P arrow stack T minus minus. That is, it stores the output, or it going from the stack T minus minus to the P. For each field in T++ or for each field p.fi, that is p.file, then do the following operations. Like if p.fi is a reference, that is p.file is a reference and object p.file is not marked, then mark the object p.fi, then pointing or incrementing the stack pointer, that is T, and store in the p.fi. So this is an example of the mark phase. In simple terms, the algorithm that is used is the depth first search, and first of all check the reference object. If the reference object is marked, then it's okay. Otherwise, mark the reference object and then allocate the memory to the stack pointer. Now next is your sweep phase, that is a winding up phase of the deallocating phase. So first of all, there is a P, that is the first address in the heap. Now check the condition, that what is the condition? While P is less than last address in the heap, that is continue the loop, iteration will continue until P is less than last address in the heap. Then check the condition. If the mark object P, then unmark the object P. That is, if there is a mark object and we have reached the last address in the heap, then unmark the object P, else let F be the first field in the object P. That is P dot F is equal to the or going to the free list. Then putting the P to the free list. That is putting the P object in a free list. That is, now P is a free. That is a sweep phase. That is sweeping the or removing the address. Then P arrow P plus size of object P. So this is the sweep phase. In simple terms, the object will be swept out from the memory. This is the example. This is a root, that is A0, B0, C0, D0, E0. Now E will be swiped out. That is, the E will be swept out. After the marking, we can mark, that is the A1, B0, C1, D0, E0, F1. This is marked. This is 1, this is 1, this is 1. After sweeping, this is same. This is 1 is converted into 0. This is 0. This is 0. This is 0, 0, 0. And how many items will be freed up, swept up? That will be marked. This one, 1, 1, 1. This will be freed. Now, what is the problem, or what are the problems in the mark and sweep? First of all, there is a problem of the memory fragmentation. So there is a difficulty in the memory fragmentation, that is, we cannot divide the content of the memory, that is the memory fragmentation. Then next problem is that work proportional to the size of heap, that is, the work is properly proportional, or work is proportional to the size of the heap that is required. Then potential lack of locality of reference for newly allocated object, that is, there is a lack of locality, there is a lack of reference object that is available for the locality of the reference for the newly allocated objects. So these are the various problems. First problem is there is a difficulty in the fragmentation. There is a difficulty in the work proportional to the size of the heap. There is a difficulty in the locality of the reference for the newly allocated objects. So these are the three problems that is used for the facing in the mark and sweep algorithm. Then what is the solution of handling this problem? The solution of handling this solution is compaction. That is, use the compaction or do the compaction, that is use the contiguous live objects, that is use the connected live objects contiguous free space. That is first of all mark the object that is nearby with each other, then sweep the object that is also nearby with each other. So solution is compaction, that is pick the objects that is nearby with each other, so that the memory will be allocated or memory will be deallocated in a contiguous manner. Now these are the examples of the mark and sweep example. This is the root set, the same example. This is root set, this is root set, this is the heap space. This is again the heap space. There is a dotted line, then there is again the dotted line that is come, then free the unmarked cells. This is the unmarked cells, this is the marked cells that is not used, and then free the unmarked cells. So this is free the unmarked cell. Which are the cells that is unmarked? This is and this is, and these are not unmarked cells. Then mark, sweep, cost and benefits. That what are the cost and what are the benefits that is used. It is good to handle the cycles correctly. It is good that is no space overhead. 1 bit is used for marking cells, that is no spaces overhead is required. These are the benefits. Then what are the limitation, that is a bad condition, is that normal execution must be suspended for a moment, for a time. Why? First of all mark the objects, then sweep the object that is unmarked objects. Why? Next limitation is that may touch all virtual memory pages, that affects or may touch all the pages of the virtual memory. Again the next limitation is that heap many fragment, or heap may fragment, that is sometimes the fragments also takes place automatically whenever we use the heap memory. Now next part of or next category or the next technique that is used for the garbage collection is the garbage or copy collector or copying collector. This is the next technique that is used. So this says divide the heap into free space and the to space. That is, divide the main memory or divide the heap memory into the free from space, that is from it is come, and to the to space, that is from where it is come, or from where it is stored, that is the from and the to. Then next point says the cells in from space are traced and the live cells are copied into the T space. That is, first of all cells in from space are traced, that is cells are coming from the from space are traced, first of all tackled, and then live cells are copied into the to space. So first of all from space the cells are traced, and then the live spaces are copied into the S space or into the to space. This says to keep the data structure linked, must update the pointers for the roots and cell that points to the to from space. This is why references in Java and other languages are not pointers but indirect abstraction for pointers. Only garbage is left in from space. That is, first of all divide the heap into two categories, that is the free space and the to space. Then cells from that or cells in the from space are traced and the copy to the to space. Then use the data structure so that only the garbage is left in the from space and all the data is going into the to space. When to space fills up, the role flip, that is the roles flip. That is, all to space become from space and vice versa. That is the first of all the old one, that is the to space, becomes the from space and the vice versa. Then next is how to copy a linked list. This is the example. This is the Cheney algorithm. This is the example. This is the pointer. This is the forwarding address. So these are the pointers that is used. This is the from space. This is the to space. Now this is marked to space. This is comes A, B, Then cells in two space are packed. So this is the from space, this is the two space. Now this is the permanent, that is the two space, and the from space can be deleted by using the sweep phase, by using the free function. Then next is again how to copy a database, that is the cells in the two space are packed. This is B dash, this is C dash. Again this is also a toggle. Now flipping the spaces, how to flip? First of all, there is a from, there is a to. Now this is a to, this is a from. Now what are the trade-offs, or what are the strength and the weaknesses of the copying or copying the copying collector? That is, it is very good for the low cell allocation overhead. That is a very low cell allocation overhead, means there is no more than one cell that is required, or there is no overhead, there is no more cost is required for the cells. Then next good thing is that compacting. It is very good in the compaction, that is we can use the it can eliminate the fragmentation, or we can use the contiguous blocks of cells. Then what is the limitation? It twice the memory footprint. That is twice the memory footprint that is used. Then next is your generational garbage collection. So this is the next technique. The first technique that we have studied is mark and sweep. The next technique that we have studied right now, copying collector. Now next one is your generational garbage collection. This says the observation is that most cells that die young. That is, most cells, that is most part of the tree are dies at the young stage. Nested scopes are entered and exit more frequently, so temporary objects in a nested scope are born and die close together in time. Inner expressions in scheme are younger than the outer expressions, so they become garbage sooner. So this is the main problem, that cells die in a young stage. Now in generation garbage collection, divide the heap into different generation and GC the younger cells more frequently. That is, the GC is used for the younger cell, that is don't have to trace all the cells during a GC cycling. Periodically heaps the older generation, amortize the cost across the generation. So divide the heap memory into different generation, and GC allocates the different memory and free the memory from the younger one cells more frequently. It means the generation observations, means the generation GC also measure youth by time or by growth rate. It cannot live, that is 50 to 90% of objects die before they are 10 kb old. Then Glasgow Haskell, that is 75 to 95% die within the 10 kb. Standard ML of NJ reclaims that over 98% of objects of any given generation during a collection. These are the various observation of the generation, or the generational GC that is used for the observations. Now examples with the immediate aging. This is the immediate aging. There is a young, this is the young, this is the old one. This is the use rate. Now A and B become AB become old one. This is the youngest one from the from space. This is the from, this is the to, this is the middle generation, this is the from, this is the to, this is the older generation. That is the dividing the main generation into multiple parts. So this is the diagram, this is the example that shows what are the observations. This is the method that is used. This is the example of the young and the old. First of all, they are young, now they are old. This is a generation with the semi spaces. That is a from, that is a to. This is the youngest, this is the oldest. Then what are the practical issues of these old methods or technology, or what is the practical issue of garbage collection? First of all, unpredictability. That is, we cannot predict major concern is on critical applications, plus support collection, support collect off, support collect now. Then next is the efficiency, that is the generation scavenging, that is the clustering. Then incrementality, that is the separate the GC thread running the concurrent or concurrently. Next is your incrementally, that is using the or in increment way GC runs a various stacks, various object in a concurrent way, in a continuous way. Then finalization, that is recycling the non-empty or non-memory resources, that is final the objects. Then external calls, that is interfacing with other languages, that is the external code, that is the GC also interface with other languages. So thank you so much everyone, that's all for today's session. Now if you have any questions, then please text the question and I will answer you. So that's all for today's session. In the tomorrow's class I will be starting with the next topic, that is your 11th topic. Now let's see what is the 11th topic. I think that is the memory related bugs in the C language. That is, what are the bugs or what are the types of bugs that is available in the C language. So that's all for today's session. Thank you so much everyone. Now if you have any doubts, then please text the doubts. So that's all for today's session. Thank you very much.